Good morning, good afternoon, and good evening to all of our attendees joining us today for this latest Data Science Central webinar. This is Bill Vorhies, your host. I'm the Editorial Director with Data Science Central and also Chief Data Scientist for Data Magnum. I'd like to start off our event today by thanking Tableau for sponsoring today's event. Tableau is a longtime supporter of the Data Science Central community, and we're honored to have them sponsoring our event today. Now, past webinars are available on demand at datasciencecentral.com, and if you haven't had the opportunity to view them, I encourage you to take a look. They provide some very useful insight into a wide variety of topics of interest to our data science community. Now, today's webinar is entitled The Promise of Natural Language Processing, and of course, that'll be presented by Tableau. Before we begin, I'd like to briefly review the format for today's webinar. Today's event will be an hour long. We have one presenter who I'll introduce in just a minute. There'll be 10 to 15 minutes of Q&A following the presentation. And this event is being recorded and will be available on datasciencecentral.com later this afternoon following today's live event. Now, I'd also like to encourage our attendees to provide questions throughout the presentation, as we'll be reviewing and presenting them on your behalf during the Q&A portion of today's event. Now, I'm very pleased to introduce today's speaker, Vidya Setlur with Tableau. Vidya is a senior research scientist at Tableau and the technical lead in the natural language team at Tableau Software. Previously, she'd worked as a principal research scientist at Nokia Research Center for over 7 years. She graduated from Northwestern University in 2005 with a PhD in computer graphics. Her research interests lie at the intersection of natural language processing and computer graphics in the area of content retargeting and iconography. So Vidya, thanks for being with us today. We're looking forward to your presentation. The rising popularity of Amazon Alexa and Google Home has led people to expect when they speak to software, it'll understand what to do. Now, this concept is also ascended in the world of data, making it easier for everyone to ask questions and conduct rapid analysis. So in today's Data Science Center webinar, we'll investigate the potential of BI software to intuitively understand human language as it's written and spoken. So in today's webinar, we'll provide an introduction to natural language processing, NLP, examples of how NLP is already used in Tableau's geocoding and map search, and a demonstration of some research prototypes that you might see in the not-too-distant future. So Vidya, with that, I'm going to turn it over to you. You can begin as soon as you're ready to go.
Thank you, Bill. All right, so I will start off by talking about how we are actually using natural language to help people see and understand their data. And this is the agenda of the webinar. I will introduce the concept of natural language processing and what that means, and how NLP, which is the short form for natural language processing, is used in various interfaces, and why is it powerful, and what are some of the challenges along with that, and show an impact of how NLP is applied to the Tableau platform through a couple of research demo prototypes. So with that, let's start off with language. So we all know that language is a tool that we primarily use for conveying information and meaning, and it exists all around us, whether it's in books and words, maps, signage, or even on your devices, or information on this webinar, for example. In addition to the textual aspect of language, it's also verbal in the form of conversation that we have. And as humans, we're particularly skilled at understanding and conveying these thoughts through language. And in addition to just the language itself, we tend to use our physical bodies through gesturing and voice intonation while making sense of language. So through language, humans constantly seek meaning in our lives. We try to make sense of things around us and things that we care about. But meaning by itself is a rather abstract concept, and semantics is a way of expressing that meaning in more concrete ways. So what does that mean when we talk about statistical graphics? So statistical graphics is rather abstract because, if you take a look at this example right here, this is a log scale showing the relationship between brain and body mass for various animals. And it's rather hard to decipher patterns because you need to trace the textual labels associated with the points to figure out what the relationship is between brain and body mass for these various animals. Now, if I add a little bit of semantics where each animal is represented by a meaningful icon, the graph immediately becomes more sensible and hence more useful because our visual system can discern the pattern and the relationship directly without having to do a mental spatial mapping of the graph. So what does that mean in terms of using language with respect to a computer? And the problem is not between humans, because as humans, we're pretty trained and we're pretty advanced in terms of communicating that language. The main issue is between a human and a computer, because when people see and understand text, the computer only sees zeros and ones. So how do we actually get computers to see and understand meaning and to intelligently process what a human is communicating with it? And that is where natural language processing comes into play. It's a field of computer science and computational linguistics that is particularly concerned with the interactions between a human through natural language and the computer. So let's walk through some examples in terms of why NLP is so powerful. Pretty much all of us have used some form of an email client in our day-to-day lives. And if you've observed many of these clients, particularly Gmail, it's gotten much more sophisticated. So if I get an email with a meeting invite, it will automatically add it to my calendar, or it will show me an RSVP button. Or if I'm expecting a package, say from UPS, the email also has a track package button associated with it. So email is one concrete place where NLP has used the content that is found in the email to come up with more targeted user interaction behavior. Another example is mobile devices with the sophistication in voice recognition through Siri and Alexa. People can talk to their phone, they can quickly ask a question and do a range of stuff such as navigation to a particular place or texting someone through voice and so forth. So voice recognition has also gotten better, and it has also trained on particular accents and the ways in which people ask certain questions. And at the other end of the spectrum, we have Watson, which is an artificially intelligent computer system developed by IBM that was designed to answer questions posed in natural language in Jeopardy style. And as you can see here, the computer is doing pretty well in terms of answering these questions on the quiz show Jeopardy. So with respect to Tableau, how does this all fit in? And at Tableau, we call the process of seeing and understanding data the cycle of visual analysis, and we draw it like this. However, this cycle of visual analysis is not linear. It jumps around. It's more like a conversation that a human has with their data rather than a linear flow of data through a process pipeline. So it follows twists and turns as our understanding of the data grows. And it's important that our tools stay out of the way of this conversation so that a human can proceed in understanding and making sense of their data. So in terms of natural language and what that means, we are not considering natural language as a shiny independent box in the context of visual analysis. We basically look at natural language as yet another modality that gets a human to have this sort of back and forth conversation with their data in a natural language metaphor. So how are we actually thinking about using natural language in this cycle of visual analysis? Let's look at Tableau. This was Tableau 5.0 as of late 2009. And if you are familiar with Tableau, it consists of a bunch of dimensions and measures, which are data attributes on the left side pane. And as a user, I can drag and drop these dimensions and measures into these columns and rows on the right side to generate a visualization. So in a way, I'm having a conversation with my fields and data attributes without really having to think about the tool. It's as intuitive as drag and drop. And this is Tableau as of early 2017. Yes, the interface looks a lot more contemporary. It's less dated. But the general essence of interacting with the data has pretty much stayed the same. You still have these dimensions and measures, which are the data attributes on the left side pane. And as a user, I drag and drop these to my rows and columns to generate a viable visualization. But the way we see natural language playing a role in visual analysis is being able to easily interact with the data beyond just drag and drop. So if I were to say highest and lowest temperatures in Fahrenheit over fall, and I were to do the equivalent in Tableau's current drag and drop interface, it would involve at least two disparate interactions to compute highest and lowest, and then I would have to write a calculated field to convert Celsius into Fahrenheit, and then define a seasonal range, in this case fall, to generate this time series line chart, which is a lot of interactions, whereas in natural language, I can just ask that in one phrase or one sentence, and I immediately get a response. Another example is just facilitating natural interaction. So last week's sales in Europe, it involves two filters. One of them is temporal, where I'm filtering just to the last week. And the other one is geospatial, where I'm filtering the data to just Europe. And being able to just call two filters under the hood by just saying last week's sales in Europe is pretty powerful. And we're hoping that this sort of interaction will help broaden the reach and bring data analysis to more people. But on the flip side, as natural language has gotten more and more sophisticated and the algorithms and techniques have gotten much more nuanced, NLP is still an inherent difficult problem. For example, my son the other day was researching about caterpillars for his science report, and he went to Google and typed in caterpillar. Now, it's an ambiguity because Google doesn't understand whether caterpillar alludes to the construction equipment company or the creepy crawly kind. And by disambiguating that, by just changing caterpillar to caterpillars, making it plural, immediately Google knows, oh, okay, so you're really actually wanting to get information about the creepy crawly kind, and the results are tuned to the user's intent. Another example, because we always want cats in our talks, is this particular one, get the cat with the gloves. And if I were to go to Google Images, I would get these three top results. And they're all plausible, but they're also different. So let's dig in a little deeper. In the first example, get the cat with the gloves, it's with the gloves is a separate preposition phrase, so it means get the cat using your gloves. And in the second case, with the gloves is part of the noun phrase, so it means get the cat that is wearing the gloves. Subtle difference in meaning, but different results, even though I personally think the right side image is way cooler than the left one. So what does that mean in terms of data analysis and NLP? So if I were to give you this search bar and ask you to just type in any question you have about your data, it's really hard because it's an empty search bar and you don't have context. But if I were to add a little bit more context and showed you a map of earthquakes in the United States with location and magnitude of these earthquakes, you may probably ask, find large earthquakes near California, and then the viz would update to earthquakes that are of a magnitude that is significant around California, and you get the result. So the point that I'm making is, whether you look at the caterpillar example or the cat example or even this example, without having any context, natural language becomes really hard, because it's really hard both for the human to understand what to ask and what is the context that is in play, and also for the computer to really understand what the user's intent is. So there's always a need to come up with clever ways to really define the context of a task so that the workflow is more defined for these natural language algorithms to take effect. So with that, I will love to show you a demo to kind of walk through how we're thinking about natural language with respect to helping a user perform data analysis. So I'm going to share my demo in a few seconds. All right. So this is a web page of a research prototype that we call EVISA, and these are earthquakes in the United States with various magnitude and location data tied to it. And I can start off by asking, show me the large earthquakes. So you see that the map gets updated with a subset of points that allude to large. And if you notice at the bottom here, there is a slider which shows me a magnitude of at least 5 or greater, because large is an ambiguous concept. What does large mean? It can mean different things for different people. So what the computer does is it actually gets some domain knowledge from outside and comes up with a best guesstimate and says, okay, I'm going to set large to be 5 and greater. And another point that I'd like to make is, because the context of the workflow is defined to the computer, and the computer knows that I am looking at earthquake data, large can be mapped to magnitude because they're semantically similar concepts, as opposed to an empty canvas where the system does not really know what you're alluding to. And I can go here and as a user say, you know what, I'm actually going to update large to be 4 and greater, because to me earthquakes are scary. And the system automatically updates that accordingly. Now I can continue and say, show me the large earthquakes near California. And the system updates to large earthquakes around the area of California. And if you notice, large is still mapped to 4 and greater, because in my previous interaction, I corrected the system to 4, and the system remembers that, because it would be really frustrating if I have to go back every time and modify this slider. And there's another slider that's pertaining to this concept called near, which is another fuzzy concept. What does near mean? Does it mean 100 miles around California? Does it mean 200 miles around California? So that ambiguity is also recognized by the system and expressed as a slider. Now, we do some smarts underneath the hood to come up with some good guesstimate about what near might be. And that's really based on the geospatial density of the points. So for example, near in the middle of Montana would be very different from near in a very busy metropolitan city such as Paris. So we do try to come up with some reasonable guesses, but as a human, I can always go and have a conversation with my system and correct and clarify. It's very similar to a human conversation where I might ask a question, you may not understand what I'm saying, and you ask for clarification. So moving on, I can continue and say, how about near Texas? And if you notice here, large is still mapped or carried over to this question, even though I did not explicitly say, show me the large earthquakes near Texas. And this is a concept called pragmatics. It's a very inherent or intrinsic part of human conversation. So if I am talking to you and say, you know what, I'm actually vegetarian, and you come back to me and say, would you like to go to some vegetarian restaurants nearby? And the conversation is rather odd because just before that I said I was vegetarian, so a natural follow-up would be, okay, shall we go to some restaurants nearby? And the other person already knows that I'm vegetarian. It's a very similar analogy. So rather than saying, how about large earthquakes near California, large earthquakes near Texas, I can just pivot off of previous conversation, and the system understands that. So it makes the conversation flow feel a lot more natural when I'm interacting with the computer. So let's go to another example here. So these are temperature data in New Zealand. And I can start off by saying temperatures in March. And it will update the data to show me temperatures in the month of March. Now, I can also say temperatures near March. Now, again, near is a fuzzy concept. But in this case, unlike the map, the system knows that near alludes to a temporal fuzziness because the context here is a time series line chart. So that ambiguity is expressed in the form of these ambiguity widgets, which are calendars that pad March to be a month before and after March. And as a user, I can go and change this to something else, and the system will update accordingly. There's also some built-in semantics, so I can say in fall or spring. And these are concepts that are not part of the data, but they're common knowledge concepts that the system has stored. So I can ask these questions that are more expressive, even though they're not found in the data. And if you notice here, the temperatures are actually in centigrade, and I can also convert it into Fahrenheit. And there's an auto-completion option if I don't want to spell Fahrenheit, and it will convert. And I can also say, show me the min, max, and average. So imagine doing this in a tool that is a drag and drop interface. It would be incredibly hard because I would have to do 3 separate interactions to get to the minimum, maximum, and average temperatures. But in this case, I just asked a question in one shot, and I was able to see the response. So that's pretty convenient, and that's kind of where we see natural language playing a pretty deep role in helping people interact with their data a lot more seamlessly. So walking through another example, this is a bar chart showing various GDP values by country, and I can say highlight GDP between 5,000 and maybe I can choose the max. So there is some smart auto completions that knows, okay, you're referring to GDP per capita. So I'm going to do a fuzzy match between GDP and GDP per capita. But I can also give you hints about what the domain range of those numbers are if I want to use those as guidelines to figure out how I want to ask my question. And I pick up this subset, and it highlights the bars in play. But really, when I want to look at these and compare these bars, I probably want to sort them in, say, ascending order so that the bars can rearrange, and I can do an easier pairwise comparison between these highlighted bars. So if you notice here, the bar chart shows various countries, but I can also ask questions at a different level of detail. So if I say, find North America, it will highlight Canada and the United States as being part of the continent North America. You could also do this, color by region, so I can see all the countries that are in play. colored by these regions, North America, South America, and Central America. So this kind of gives you a sense of how I could ask a question with a single viz in play, and how ambiguity, in this case region mapping to subregion, or any semantic ambiguity can be exposed to the user. In addition to single visualizations, we can also ask questions of a data source or a dashboard. So let me go to this dashboard, which shows various disease outbreaks around the world. And I can start off by saying measles in the UK. And it will update my points to being around United Kingdom. And in this case, I used an abbreviation UK, and they're built-in concepts for place abbreviations, for example, that it can recognize that I'm talking about United Kingdom, and widgets are exposed to the human or to the user to expose the underlying understanding that the computer is having of your natural language questions. And I notice here that there is a spike, and I can just say, show me the orange spike. And immediately I get a pithy annotation that is generated off the fly on this line chart. And even though I have multiple vises in play, the system knows that when I am using the word spike, that alludes to a line chart, and the line chart responds to my question. I can also ask something like this, mumps over there. So you notice that I did not say mumps in the United Kingdom. This is another example of pragmatics where I'm already in the United Kingdom and I'm just interested in another disease, so I just say mumps over there. And the system just changes from measles to mumps and updates the dashboard accordingly. So let's move on to some other region. So I could say measles epidemic in Malawi, Congo, Angola. So a slightly longer question, and it shows me measles in these 3 African countries. And then I can proceed by just saying deadliest. And there's no data attribute called deadliest, but it's mapped to fatalities because, again, the system understands the context that is in play and exposes the ambiguity of deadliest to being the top 10% of the fatalities. And it's shown as an ambiguity widget. And as a user, I can go and change that if I need to. So let's move on to another example. Let's go to housing data. So this is housing data for various neighborhoods in Seattle. And some of the data attributes here are sale price, square footage, home type, number of bedrooms, number of bathrooms, sale date, and so forth. And I can ask a question such as, show me houses near Ballard. Okay, took a while to update because there's a lot of data points. And I can further filter that to under 400K if I need to. Let's start off with another example, average price by neighborhood. All right, so in this case, the system knew that it cannot answer this particular question using the map, so it generates a bar chart using these data attributes. And I can again go and say sort descending, and it will sort the bar chart, and the map doesn't change because the system knows that I'm alluding to the bar chart. I'm also interested in looking at this data over time, so I can say average price over time. and it shows me a line chart. And I know that there's home type as one of the dimensions, so I can just say by home type. And it knows that I just most recently added a line chart through my previous question, so it breaks the line chart into 3 lines, conforming to condo, townhouse, and single-family residential. So that comes to the end of my demo. And with this, I'm going to go back to my presentation. So to summarize, the way we are thinking about natural language at Tableau and in general with data analysis is fundamentally through these 4 principles. The first one is understanding that there's always going to be ambiguity. We cannot design a perfect system, and it's perfectly normal to acknowledge that there's ambiguity and expose that ambiguity back to a human to help clarify, pretty much like a real conversation. The other aspect is the notion of pragmatics, so being able to have this natural conversation where I can ask questions pivoting off of previous questions so that the context is known and carried over. The third aspect is having a deeper knowledge about semantics so that the questions can be more expressive. And lastly, we are looking at natural language being a good player with other modalities, whether it's drag and drop, mouse interaction, voice, and so forth. So walking through these a little bit more in detail, just looping in and summarizing what you saw in the demo, being able to recognize concepts such as large and near, which can be ambiguous and depend on different models of how people perceive these concepts, and exposing that back to the user through these ambiguity widgets and updating the viz accordingly. Another example is time. That's also an ambiguous concept, and making sure that the widgetry conforms to that concept. So in this case, if it's time, showing a calendar, for example. Another concept is pragmatics that I talked about, being able to ask a question such as this, and asking a follow-up question such as, how about near Texas? And getting the system to understand that without having to specify every single token in the phrase and responding accordingly. In addition to pragmatics and context, we also want to support general level semantics, such as Fahrenheit and fall, and being able to convert this stuff under the hood and showing a response. In addition to just general knowledge concepts, we also are looking at supporting interfaces where as a user, I can go and define my own domain-specific concepts, such as concepts that might come up in finance or healthcare, so that the system can use those as well in its underlying model. Also being able to take examples such as 600K and mapping that directly to house price without having to specify that directly. So in this case, the system knows that 600K is a number, and it maps it to a numerical attribute in this dashboard, which in this case is sale price, and updates the visualization accordingly. Also being able to support questions that allude to the properties in the visualization, whether it's color, whether it's a mark type such as a spike or a shape such as a circle in the map, and being able to not only ask questions about the data attributes, but also the visual attributes in play as well. In addition to that, we see a natural trajectory for natural language to go into the mobile space. At Tableau, we also have been developing mobile experiences, and we see that natural language would be a really nice fit to that, especially with the touch screen and voice, where I can select or lasso a bunch of points on my screen and ask questions about it. In this case, it is earthquakes that have a certain magnitude over here, or I should be able to just talk to my device. The types of questions might be different on a mobile device, for example. It tends to be more fact-finding, where I might just be interested in last sales in the quarter of 2017. But we can also envision more exploratory data analysis using touch, for example. So in addition to development and productization of this feature, we're also actively thinking about research and what that means in this whole holistic experience of NLP and Tableau. So we annually at Tableau, we have a customer conference, which is a really big deal because customers from all over the world come. We meet in one place and we talk about Tableau and more broadly about data analysis and how we can actually design tools that help people in this analytical workflow. And as part of that, last year, we had this Wizard of Oz study, which is basically a type of design study with a human who mimics a wizard behind a computer screen, and there's a participant who will ask a question, and the wizard will update the visualization accordingly. So it's all human, but it's done behind a screen, so it's called Wizard of Oz. And so we were looking at different ways in which people were asking questions, and what are the types of visualizations that they expected with respect to those questions. And what we saw was this underlying premise that we call intent, which is simply understanding what the analytical needs are when a user expresses a natural language question. And there's a certain richness that comes to bear when people ask these questions. So how can we actually decipher this intent from this natural language input and then provide more analytically useful visualizations as responses? So let's take an example. If I were to ask this question, what are the top manufacturers by city MPG? And Tableau, particularly the Show Me feature in Tableau, would return this bar chart, which is unsorted as a response to this question. But if we understand that the underlying intent of this question is to compare these various manufacturers in terms of city MPG, a more analytically useful response to this would be a sorted bar chart in this case. It's a very simple adjustment to the response, but it is really profound in making sure that these tools help a user as opposed to coming in the way. Another example is a question asking if these two attributes are in fact correlated, so city and highway, and Tableau just returns a scatter plot with a single dot on the upper right corner, which is not very useful in terms of understanding these patterns of correlation. So instead, we probably want to unaggregate these measures so that people can actually see a pattern to figure out if these two measures are in fact correlated. So another example in which we try to decipher the intent from these natural language conversations to produce more analytically useful visualizations. So with that, these are some research papers that are available on our Tableau website. If you're interested, feel free to go through these papers to get a deeper understanding on some of the underlying technical algorithms that come into play, particularly in the demos that I showed you. And at this point, I will hand it over to Bill to moderate Q&A.
Well, Vidya, thank you for that excellent presentation. And we'll get started on the Q&A session right away. And I want to thank the audience for their participation. We've had a lot of questions that have come in, and we'll do our best to get through all of them in the time remaining. And so during this Q&A, I'll leave up this screen with contact information for Vidya if you'd like to contact her following today's webinar. So Vidya, wow, the audience is obviously really excited about this feature, and the questions kind of break down into, boy, how soon and how do we get it, and then how does it work? So let's talk about some of the simple ones first. So is this NLP feature available now on Tableau desktop?
That's a great question, and we get that a lot. We're currently productizing this feature actively. We have an engineering team, and we're going full blast into productization. So you should expect seeing this feature pretty soon, probably close to the end of this year.
Okay, and will it be? Will I be able to do this just on Tableau Desktop, or will I need to use Tableau Server to access it?
Right now, we are looking at shipping this feature online and on Tableau Server. That being said, we do have a roadmap of evolving this feature onto other products as well.
Okay, and so if I understood that correctly, it'll be both server and desktop, which I believe answers another question which was asked, and that is, would the user need a direct cloud connection? And I think you said then no.
Right. I mean, we are looking at rolling out this feature both on Tableau Online, Tableau Server, Tableau Desktop. The experiences around these various products will probably be a little bit different depending on the needs. That being said, there are some finer details that we're working out in terms of what types of accounts Tableau users need to access these features. So that's still coming, and that's still TBD.
Okay. Well, the audience wants to push you as far and as fast as you can go. So the next question is, what about mobile? And we're going to end up having a wake-up word like, hey, Visa, tell me about this data.
Yeah. Yes, absolutely. Mobile is definitely a very logical place where we want to take this feature. Currently, we are focusing on getting the experience right in a desktop, type of interface for now, and figuring out ways in which we can take some of the underlying NLP engine and translating that into a mobile experience. So that is also in the works, but that will probably come in a little bit later.
Okay, and I'm guessing then that support for languages other than English is also in the pipeline, but just we have to wait.
Yes, I think the focus is getting the experience right and starting off with something that at least we have a handle on and we have understood. So we will start off with English, particularly English US, and then make our way to support other languages that Tableau normally supports.
Terrific, thank you. Now, one user asked a question that frankly I was thinking about too, and that is, while you've used text to make specific queries of the data, what are your thoughts about expanding this to the ETL function in which we define the data that flows into Tableau? Can I look forward to a time when we can say, reach out and get me the data from X file?
Yeah, absolutely. While Tableau has focused a lot on data governance, where as a user, I can bring in data from various sources using different connectors into Tableau, another aspect that you highlighted is what I call semantic governance, being able to pull in specific concepts or domain-specific language that will help me with my natural language interaction. Because it's really hard coming up with a horizontal general set of concepts that work for every single Tableau customer. We have customers from school teachers all the way to healthcare, hospitals, and it's a wide gamut. So rather than trying to load in every single concept that we can possibly get to for every single customer, we want a customer to feel empowered and being able to easily pull in or import data that would facilitate their natural language interaction as well.
Terrific. And so the audience has asked some questions that would like to drill down on what you just said. For example, I presume that what you defined as pragmatics, kind of the tables behind the scene, are part of that I would pre-train. So I guess the first issue is customers will be able in some way to add training to your NLP. Is that right?
Yes. As with any natural language feature, we do suffer from a cold start problem. So if you think about Amazon back in the day, the recommendations that Amazon was providing for books was pretty simplistic because there was no data or training data because it was a brand new feature. And we're in a similar boat. We have not released this feature out in the wild, so we still need to collect feedback. We need to collect data in the ways people ask questions or how they correct the system. And once we get enough data, we will have a useful training set that can be used to surface some machine learning algorithms to make the system even better. But we're not there yet because we still need to put it out before we can actually apply machine learning.
Yeah, you could tell from these audience questions that everybody is just really excited to have this and wants it to do everything all at once, and that'll take a little time.
Yes.
Another question that comes in, for example, contextual information. The example, for example, is how does Evisa recognize, for example, the concept of North America when countries haven't been identified by continent? Is that contextual information part of pragmatics, or
that's a great question. Actually, that particular data source is a hierarchical data source. So those countries are part of a geospatial hierarchy of which North America is part of. So that just came for free because of the data itself. Now, that being said, Tableau has a pretty comprehensive geospatial data set where we have abbreviations, we know the continents, we know the countries that belong to each continent, we know the cities. So even if the data does not have that underlying hierarchy, we can infer that. In general, space, geospatial, and time are pretty well-defined concepts that we can take advantage of. And the nice thing is, a lot of the questions that people tend to ask are mostly geospatial and time. I'm not trying to generalize, but those are the two, more predominant concepts that people tend to ask. And the nice thing is they are pretty well defined.
Okay. Now, the audience is really trying to push out the limits here. And we know that with some NLP applications, they are capable even of detecting something about human sentiment. And I know Tableau is about the interpretation of hard data. Is there a crossover between Tableau's presentation of data and perhaps some element of sentiment analysis?
Yeah, so sentiment analysis is a technique that is part of text analysis, and natural language it's also used in that case as well. So being able to take bodies of survey data, for instance, and trying to figure out are these surveys negative or these surveys positive. So while we are focused on using natural language as a modality for asking questions, there are different aspects of the analytical pipeline where NLP can be used. And I can only see this expanding to other parts of the product. So one of them is text analysis, such as sentiment analysis. Another aspect is just data cleaning, being able to say, these are all names, and I want to split them into first name and last name. And the underlying algorithm has access to survey data, for instance, or census data, and can say, okay, these are all the first names and these are all the last names, so I can split the data column automatically. So data cleaning, being able to bring in general level concepts, being able to analyze text data, these are all just different facets of where NLP can play a role in this product, and I only just showed you a tip of the iceberg at this point, almost like a teaser.
Yeah, and the audience is responding, believe me. One of the things that caught my attention as well as the audience is toward the end you showed the correlation analysis, and so the direction of our thinking is, wow, can I simply at some point in time ask Tableau to predict something in the style of a predictive model?
Yes. So in addition to NLP that's being researched and engineered at Tableau, we also have a team that's looking at advanced insights. So being able to take a look at the data and see, oh, this is maybe an anomaly, or this is an interesting pattern, and being able to bring that back to the user. I would say, though, just more from a philosophical standpoint, we don't envision these buckets of smart technology, as you might call it, to completely replace a human. There's always value of having a human in the loop when she's going about doing data analysis. Rather, we want to provide tools that help this user perform data analysis a lot easier. So in the case that you said, being able to say, these are some interesting insights, what do you think? And the user provides follow-up feedback, and the system learns from those patterns. That's basically the paradigm that we're aiming to go. So it's a hybrid model of figuring out the right amount of automation, but also acknowledging that in many cases a human would be better equipped than a computer.
Oh, good. That means that for those of us that are still in the drag and drop world, you're not going to completely replace our good old familiar drag and drop with NLP. Yeah.
Right.
Would you like to give us a little deeper dive into the background on natural language processing and the use of deep neural nets to interpret speech, recurrent neural nets, and LSTMs?
Sure. So Evisa in particular has a very simple model where there's an underlying grammar where the grammar updates in real time based on the data that is found. And rules are also, there are some preceded rules to come up with recognizing general level questions. But some of those rules are also added dynamically, especially when you're looking at pragmatics, to figure out what are some new rules that the system needs to define in real time based on how a human is interacting with the computer. Now, if you go to more of the other technologies such as neural networks and so forth, those tend to have an underlying training set where these rules are defined ahead of time based on this training set and refine over time. Now, as I alluded to before, we are suffering from a cold start problem, and also the data sets that people tend to use with NLP are so different from one another. So it's really hard to come up with a neural network that takes all the concepts available for that data set and make it comprehensive ahead of time for every single user. So what we're looking at is more of a hybrid approach where we have a preceded context-free grammar that gets updated in real time with concepts. For more detail in terms of how we use certain neural networks, including word-to-vec, which is a word vector that is dynamically created with respect to these concepts, I'd really encourage the audience to read some of the papers that I posted at the end of my talk, because those papers go into a much deeper level about the algorithms and the techniques. And I'm happy to also answer any questions offline once people have taken some time to read those papers.
Terrific. Oh, well, thanks for that explanation. And by the way, in terms of release date and that sort of thing, I presume that there will be a big splash, and it won't be a secret when this comes out.
Correct. Well, you will definitely hear about it when it does come out, but we are working on it pretty fast, so it's coming.
Yep. Well, it's clear that the audience is right in line with you. They really want this feature. Well, Vidya, thank you. Those were some great answers to some very good questions. And for those of you that asked questions that weren't answered today, we'll be sending all the unanswered questions to Vidya and the Tableau team so they can follow up with you after today's webinar. I have just a few quick announcements. If you would please mark your calendars for March 15th, that's this Thursday, and that's our next DSC webinar, which will be Practical Human-in-the-Loop Machine Learning, to be presented by Crowdflower. Also remember that today's taping will be available for on-demand viewing later today, and you can find that on the home page of Data Science Central in the Webinar tab located at the top of the page. Well, this brings today's webinar to a close. I'd like to thank our audience for their attendance and thoughtful questions. A special thanks again to Tableau for their sponsorship, and particularly our speaker today, Vidya Setlur, for her insights into today's topic. This is Bill Vorhies. I'm very pleased to have been your host for today's event. I look forward to seeing you all again on March 15th. Have a great day.
Thank you.